James, and in this tutorial we're going to use a calculator to work out residuals. Residuals are important in statistics because they help us to decide whether the linear model that's been used in a scatter plot is the best model to use. In this example, we have the staff at a particular swimming pool have recorded the daily attendance and daily maximum temperature in degrees Celsius for the first 16 days in January. So you can see on the first day the daily maximum temperature was 20 degrees Celsius and there was an attendance of 1,432 people. And this continues for the other days. So I'm going to record these results on the calculator in Lists and Spreadsheets view, and I've done this already to save time. So the temperature, TEMP, is short for temperature, ATT for attendance. So let's go straight to Data and Statistics view and plot these points as a scatter plot. So I'm going to tab to the x-axis and make temperature the independent variable, and then tab to the y-axis and make attendance the dependent variable. You'd expect attendance to depend on the temperature, and as you can see, as the temperature increases, so does the attendance. So there is a moderately positive linear correlation between temperature and attendance. Now, what is a residual? Well, in order to look at residuals, we need to insert the least squares regression equation, which is what I'm going to do next. So that's Menu, Analyze, Regression, Show Linear mx plus b. There's the equation of least squares, and remember it's the line of best fit of these points. Now, a residual is simply the difference between the actual y value that's given by the point and the y value that is predicted by the least squares regression equation. So in this case, it's the difference between the actual attendance and the predicted attendance. We can see this more clearly if I go back to the main page, where I've taken a snapshot of the scatter plots, and you can see the least squares regression line of best fit has been drawn in. So I can illustrate a residual. If I take this point here, the residual is that distance between the actual y value and the predicted y value. I could take this point here, and the residual will be this distance between the actual y value of that given by that point and the predicted y value. Let's take one more point. That will be the residual for this point here. So they're quite small distances. So just remember that the residual in this case is the difference between the actual attendance and the predicted attendance that you would get from the least squares regression equation. Now, sometimes the residual is positive if the point is above the least squares regression line, and other times it will be negative if the point is below the line of best fit. So let's see if we can get the calculator to work out the residuals. I'm going to go back, hit Control left arrow, go back into Lists and Spreadsheet view, and you can see I've got a heading here, predicted attendance values. So I'm going to use the least squares regression equation to make the predictions based on these temperatures over here. So to do this, I'm going to use this formula cell, which is this grey cell. So I'm going to put the pointer in there and enter the least squares regression equation, which was 138. You can just see it down here too. I'm just copying this. 138.29 multiplied by x. Now x is going to be the temperature, so I'm going to type TEMP. You must type it exactly, that column heading, minus 1,443.54. I'm going to hit enter. and those are the predicted attendances based on the least squares regression equation. Now the residual is, as I said before, the difference between these two values, so we can easily get the calculator to work those out by clicking in this formula cell and simply taking the actual attendance, which is ATT, that heading, and subtracting the predicted attendance, which is PRED ATT, and hit enter. So you can see the residuals have appeared. Now it might be an idea to round these to the nearest whole number, so I'm going to go back to this formula cell and adjust this formula slightly. So I'm going to put round in front, bracket, and I'm going to use round, which is a built-in function, and put comma 0, so that will round it to 0, these numbers to 0 decimal places, and hit enter. Now it says this operation may overwrite data. Yes, I wanted it to overwrite it. So now I've got the calculator to round these numbers to the nearest whole number. So you can see the formula at the bottom here. So we've got a column of residuals, and we also have the temperatures in this column. The next step is to plot the residuals against the temperature. So I'm going to go back into data and statistics and tab down to the x-axis, and I'm going to choose temperature again as the independent variable, and I'm now going to tab to the y-axis and choose my heading that I use for residuals as the y variable, and there they are. Not sure why I've got a circle there, but anyway, you can see the points are scattered about the x-axis, and if you look at these points, there's no real pattern to them at all. You can see there's an outlier down here, but what I've actually plotted here are the residuals, which is the difference, remember, between the actual y value and the predicted y value. Some are positive, some are negative. Now because there's no clear pattern, we can say that the linear model that we used on that scatter plot is quite appropriate. And that's how we use residuals to decide whether the model we've used is appropriate or not. Now I'm going to just summarize this. You can see the data, daily temperature, and the residuals I could have easily copied from my lists and spreadsheets into this table, and there's a snapshot again of the residual plot, and summarizing, there is no clear pattern, so it looks like the linear model may be the best model and will give a good fit to the data. I'm just going to show you one more thing. We can go back to the calculator. Now I actually worked out the residuals from scratch using lists and spreadsheets, which is quite a good idea, especially if you want to copy the temperature and the residuals into a table, as I did down here. You can see this table where I copied the data. But there is a quick way of getting the residuals from the calculator, and I'll show you how to do that as well. We can simply go back to the original scatter plot that we had of the data, that's temperature against attendance, and you can get the residuals directly by hitting menu, going to analyze, and there's the option 7 residuals, and you go to 2 show residual plot, and there it is. You can see the residuals have been plotted below the original scatter plot. So it's exactly the same pattern as we've got down here. Now you could get get the actual residuals from this plot by moving the mouse over each point, and you can see it gives the x and the y coordinates. The residual for that point there is -72, so you're looking at the y coordinate, for that point there is 1087, and those would be the same values that I recorded in the table. So that's another way of getting the residuals.